Hello everyone, I am Sriniketan. I am from the branch CSC Regular Subject Basic Electrical Engineering and my ID is 24011805006 and the teacher name is G. Raju, Assistant Professor in the JNDH and he's from the Triple E department. Today's my topic is about the mesh analysis. First, what is a branch? A branch is defined as the part that connects two nodes such that it contains a circuit element. If the branch belongs to only one mesh, then the branch current and the mesh current will be equal to each other. Procedure of the mesh analysis is: Step 1. To identify the methods and label these mesh currents in either clockwise or counterclockwise direction. Step 2. To observe the amount of current that flows through each element in terms of mesh current. Step 3. Writing the mesh equations to all meshes using Kirchhoff voltage law and then the Ohm's law. Step 4. The mesh currents are obtained by following Step 3. Immediately the mesh equations are solved. Hence, for a given electrical circuit, the current flowing through any element and the voltage across any element can be determined using the node voltages. Mesh current diagram. The below diagram is a circuit which with mesh currents labeled as I1, I2, and I3, and the arrows represented the direction of the mesh current. I1, I2, I3. What is supermesh analysis? Supermesh analysis is used for solving bulk and complex circuits in which two meshes share a common component as a source of current. Example of mesh analysis. In the given circuit, 90 volts is a battery. Value 5 amperes is a current source, and the three resistors are 9 ohms, 6 ohms, and 8 ohms. Using mesh analysis, determine the current across each resistor and potential difference. 9 ohms, 8 ohms, and 6 ohms, R1, R2, R3. So determine the ground as shown in the figure. Let the potential be VA, VB, and VC as shown in the figure. This is VA, VB, VC. Let I1 be the current flowing through the two loops in the clockwise direction as shown in the figure. VB minus V1 minus V2 is equals to 0. 90 minus IR1, I1 R1 minus R2 into I1 minus I2 is equals to 0. 90 minus 9I1 minus 6 into I1 minus I2 is equals to 0. Minus 15I1 plus 6I2 is equals to minus 90. 5I1 minus 2I2 is equals to 30. This is obtained by dividing the equation 3. Substituting I2 is minus 5. Since the direction of I2 is opposite to the actual direction of current, therefore I1 is equals to 4A. So true R1, 4 ampere current is flowing, and true R3, 5 ampere current is flowing. Now the potential difference at VA is equals to 90 volts. At VB, the potential difference is V2 is equals to I2 minus R2. Therefore, VB is equals to 54 volts. At VC, the potential difference is V3 equals to I3 minus R3. VC minus 54 equals to 40. VC is equals to 94 volts. An example of supermesh analysis. Find Ix in the given circuit. In the given circuit, we can see that 3 ampere current source is common. So supermesh analysis can be used. Applying KVL in the supermesh. 10 minus 2I1 minus I2 minus 2Ix is equal to 0. As Ix is equals to I1. 2I1 plus I2 plus 2I1 is equals to 10. 4I1 plus I2 is equals to 10. Equation 1. Applying KCL. I2 minus I1 is equals to 3. This is equation 2. Solving equation 1 and equation 2. 5I1 is equals to 7. I1 is equals to 57 amperes. As Ix is equals to I1. Ix is equals to 57 amperes. Developing the KVL equation for the mesh 1. 10 minus 5I1 minus 5 into I1 minus I2 is equals to 0. 2I1 minus I2 is equals to 2. This is equation 1. Developing the KVL equation for the mesh 2. Minus 5 into I2 minus I1 minus 10 I2 equals 0. 3 I2 minus I1 is equals to 0. Equation 2. Minus 5 of 5 into I2 minus I1 minus 10 I2 is equals to 0. 3 I2 minus I1 is equals to 0. Equation 2. Solving the equations 1 and 2. 3 I2 is equals to I1 from the equation 2. 3 I2 minus I1 put from 2, putting values in 1. 6 I2 minus I2 is equals to 2. I2 is equals to 52 equals to 0.4 amperes. I2 is equals to I is equals to 0.4 amperes. Find the current I using mesh analysis. We first analyze the current. We first analyze the circuit as it is planar. We move forward with the mesh analysis. Next, we observe that the network has 3 meshes and then assign current I1, I2, I3 to the meshes respectively. KVL in mesh 1. 5 minus I1 minus I2 equals 0. 2I1 minus I2 is equals to 5. Equation 1. KVL in mesh 2. Minus I2 minus I2 minus I3 minus 2I1 minus 2 minus I2 minus I1 equals 0. I is equals to I1 minus I2. I is equals to I1 minus I2. Minus I1 minus I2 minus plus I3 equals 0. Equation 2. KVL in mesh 3. Minus I3 plus 2I minus I3 minus I2 equals 0. I is equals to I1 minus I2. 2I1 minus I2 minus 2I3 equals to 0. Equation 3. Solving equations 1 and 3. 2I3 is equals to 5. I3 is equals to 2.5 amperes. As I is equals to I3. I is equals to 2.5 amperes. Solve the mesh and branch currents shown in figure. First, assign mesh or loop currents to the two meshes ABCA and BDCB. ABCA and BDCB. Assume the current directions as clockwise mesh ABCA. First ABCA. Minus 30 I1 minus 10 into I1 minus I2 plus 120 is equals 0. Minus 30 I1 minus 10 I1 plus 10 I2 plus 120 is equals to 0. Minus 40 I1 plus 10 I2 plus 120 is equals to 0. 120 is equals to 40 I1 minus 10 I2 is equals to 0. Is equation 1. Mesh BDCB. Minus 50 I2 minus 60 minus 10 into I2 minus I1 equals 0. Minus 50 I2 minus 10 I2 plus 10 I1 minus 60 is equals to 0. Conclusion. Once the mesh current are known, the current flowing through each resistor can be calculated using Ohm's law. The voltage drop across each resistor can also be calculated using the product of its resistance and the current flowing through it. In conclusion, mesh analysis is a powerful tool for analyzing DC circuits. Thank you.